Largest rectangle in histogram. Given an array of integers heights representing the histogram's bar height with the width of each bar as 1, return the area of largest rectangle in the histogram. So we have to return the area of largest rectangle in the histogram. We'll go over this example little later. Let's try to understand what is the sum all about. So when, for example, we have given a height of 2 and another rectangle with a height of 1. So this is the one histogram which they have given. So with this example, this is the zeroth index and this is the one index. This is again a height. This is a height and this is nothing but height. And we have to calculate area. So area is height into width, that we know it. So just try to understand. We'll come to the area later, but we'll try to understand what exactly the sum is all about. If you see this histogram, you can observe that this rectangle you cannot extend it further just because the height is 2 and the next coming height is 1, so there is no room to extend the further. So definitely if we want to calculate the area, we just have to calculate the area of this particular histogram. We cannot move it further. But if there's an other way case for this one, okay, so we just have to calculate the area of this particular, because we cannot extend the height just because there is a loophole over here because the next height is going down. Okay, so this height we will have to, this area will have to pop it because there is no room that we can extend it. So this we can pop it. Next height we are getting is 1. The catch over here is one height we can extend it backwards. You know why? Because there is no objection, because we can, this is smaller height, right? So we can extend it backwards and calculate this particular area, because there is no objection to go backwards, the height is less. And also we can extend it ahead also, there is no blockage over here. So this is a way we can try to understand this particular problem. When the height is bigger, right, when the height is bigger and the next coming height is smaller, we cannot extend that bigger height. Let's take some different example other way round. Suppose other way round is, this is one height and this is the bigger height, that is the 2. In this scenario, we can extend the one height, right? We can extend it because there is the we can extend this because there is no blockage, there is no smaller height next to it, so we can extend this particular height. But what about two? Two we cannot extend backwards since there is a smaller height, we cannot extend it. And we can still go ahead and extend further, there is nothing over here, so we can extend it, but we cannot extend backwards. So the area wise we'll have to calculate only this particular area, we cannot extend it backwards. Next, let's take a next example. Now this here, let's see the example over here. Okay, suppose this is the histogram. Okay, this is one height, this is or one height, two height, three height, then four height, and here comes the catch, second height, right? And this is, oh shit, this is one, this is two, this is three, this is four, and this is small one. One, two, three, four. These are the heights. This is the index 0, 1, 2, 3, 4. Okay, let's try to understand over here. Let's take this number 1, right? If you see in the simple array, you will see, just we'll go from first, but let's try to understand this histogram. Here you see the biggest height is 4, right? So what do you think, can we extend it further? We cannot extend it further. This histogram cannot be extended further because we know that there is a loophole over here. So if the height next to it is lesser, then we have to pop this particular area. We have to pop this particular area. Same if you check 3, right? We have to pop this particular area, and we cannot even go backwards because again the height is less. We cannot go backwards because height is less. So you have to calculate the area of this particular number. We cannot go ahead since it's a smallest histogram over here. So let's take another new example to make you more understand. Now if you have, let's take this is 1, 2, 3, 4, and this is 1. Okay, now let's try to understand this. Okay, so over here, as I told you in the previous one, same histogram, but I just wanted to explain you much more. Here we cannot extend it ahead, so we have to pop the recent one, whatever it is, and calculate the area. Next, we take the 3. Okay, let's take 3 number and try to understand the 3. In 3, we can extend it, right? We can extend it, but we cannot extend further. So the area we are calculating with a width of 2, but we have to anyways pop 3 as well because the next height coming is 1. So that's the area, that's the reason we have to pop this particular area of 3 as well. Next coming is 2, right? This is number 2. This is number 2. So we can extend 2 as well. We can extend 2 as well. If you see, I can extend 2 as well. So just take this one height as, no, I'll just make it more lesser because the 2 height is, okay, let me take another color. That was the pink one, right? So this is the one, right? This is the one. This is one. Okay, so let's go on the 2. 2 height, we cannot extend. I mean, we can extend till this length, till 4 length, because there is no lesser height. But as and when we get a lesser height, we have to pop this one. We have to pop this area because we are getting the next number is 1, which is having the lesser height. So basically, we tried to pop this particular area. We tried to pop all these 3. Obviously, I mean, we can extend this particular one. You can extend it because ahead also it is 1, so you can extend it and you can calculate this particular area. You can calculate this particular area because obviously it can be extendable, but we have popped these 3 recent ones. So exactly what we are doing with this particular diagram is like we are popping it from the top. That is first, last in first out. We are doing last in first out. This is the last in, and we are going to pop it that because our current height is lesser than whatever the stack dot peak is. So the data structure we have to use to solve this area problem is stack, because in stack we have last in first out, right? We have last in first out. So whatever the last is coming, that is 4 is coming, we are checking 1 is coming, but 1 we cannot pop it off. Next coming is 4, and 4 we have to pop it because the current height is less. This current height, the 1 is less than stack dot peak. So basically whatever top we have to pop it out. That is how our algorithm will start with the help of data structure stack, and we are using stack because it will be helpful for us to popping in and popping out easily and calculate the area. So let's try to understand how we can work out with this algorithm. So this is I will also create a stack over here which calculates the index and which calculates the height. And here there will be a max area. Okay, this is a max area. Now let's take, this is 1. Suppose this is our histogram, just drawing it out, trying to, 0, 1, 0, 1, 2, 3, 4. These are the index, and this is height of 2. This is height of 1. This is height of Let's take this height as 5. Let's take this height as 6. Next height as 2 and next height as 3. Now here we have the index. We have index and this is height. This is our stack. This is the stack data structure. Okay. Now let's take the first height. First height is 2, right? 2 is the height and index starting is 0. I'm pushing it into my stack. Now what is the area it is making? It's going to make only this area because it is not going to move ahead since the next height is lesser. So it is going to make only this particular area. So width is 1 and height is 2. So the area becomes 2. Let's go to the next one, that is 1. If you observe, 1 can be extendable. If you see, 1 can be extendable ahead also because there is nothing less than that. But it also can be extendable backwards. It can be extendable backwards. Since backward we don't have any objection, it's a less height, right? So we can extend backward. So here we have 1 height and the index I'm going to put it as 0 because we can extend it backward, and area we will be calculating ahead. Let's take number 5. 5, if you see, this 5 can be extendable forward but cannot be extendable backward because if you see, this is like an there is no smaller height we can see for the 5, so we can extend it ahead, and that's the reason we have to insert 5 with the index of 2, with the index of 2 because we cannot extend it backwards, right? So we have to calculate the index from 2, and the area wise we will talk it. We'll check the area. When to check the area? When we are popping that particular height, at that time we have to check the area. But right now if you see, all are increasing height, so we are not calculating the area and we are not popping anything. When there is a decreasing height, at that time we can calculate the area and come to a conclusion. Let's see the next. The next is 6, and 6 cannot be extendable backwards because we have 5 which is smaller height, and it cannot be extendable ahead also. So what is the 6 is at the index of 3. So if you can see that this is just one height and this is just one width. The next height is 2, right? The next height is 2. So we cannot extend 6 ahead. We cannot extend 6 ahead. So we have to pop this 6 and calculate the area. We have to pop it and calculate the area. So height is 6, width is 1. Width is 1, so the area becomes 6. That's the reason I'm going to update the area as 6. Next, let's take the fifth height. If you see over here, the fifth, we are going to pop fifth because our next height is 2, right? If you see, our next height is 2. Our next height is 2, so we cannot we have to pop 5. Next height is less, that's why we have to pop this 5. But what area it is going to make? Area which it is making is this much because 6 was increasing, so we can use that as our width and height as 5. So width becomes 2 and height is 5. That's the reason area becomes 10. Area, we are updating area as 10 and we are going to pop it. So till now we have popped 3 6, we have popped 2 5, right? We have popped this much. Now let's take next, that let's go move on ahead. Our next height is 1 and we are not going to do anything because 1 we are going to increase it. Next, we have to see the second, right? Second height. Height is 2, index is 4. Index is 4. But you can extend it backwards, that we know. We can extend this backwards. Why we have to extend it backwards? Because it's small, right? So we can extend it backwards. So for 2, we can extend the width backwards and we can use this as an area. We can use this as an area because we can extend it backwards. So the width, so the index it starts is from 2. The index it starts from 2. we can extend it backwards. So I will be writing in my stack. I don't have a room over here to write. Height is 2 and index is also 2. So I can extend it backwards, right? And the area, we don't have to calculate area because we don't have to pop it. And also we can extend it ahead as well. We can extend it ahead as well. Since there is nothing to pop right now. Next comes the height of 3. Again, here we don't have to, we can extend it ahead, but we cannot extend it backwards. We cannot extend it. So the 3 is height and index is 5. So this is our stack, right? This is our stack. And what we did is we are just calculating the area, whatever height. I mean, if we have a greater height than the current height, this is our current height, and current height is greater than the stack height. Current height is greater than the stack height. At that time, we are popping it out and calculating the area, and thus we are coming to the biggest area at the end, because we are updating our max area every time. This is the way we can solve this particular problem with the help of a stack data structure. And this is a very this is a hard problem to come to a conclusion, but for sure I hope I have made you understand by the height and by the width. And yes, we can solve in this fashion. Now let's see our code. We are using stack. If you see, I have written we are using stack, and max is nothing but the max area. I am iterating into the heights array, and the index which I am giving it is the starting index. And then I am trying to check my, this is a while condition where I'm checking that my stack size is not empty. That means it should be greater than 0. And whatever stack dot pick, if it is greater than the current height, if it is greater than the current height, this is my current height, right, which I showed you. If it is greater than the current height, then we have to pop that. And we have to pop in two ways: with the help of the width and with the help of the height, because we have to calculate the area. So we are calculating the area over here. I minus index is nothing but we are calculating the width, because we have to go at the back also, right? That's the reason I did I minus index. And then we are coming to a conclusion of max area. Again, the same steps are repeated. We are again pushing the next height and trying to do the same steps which we did in this particular upper problem. So we are doing the same steps. We are just, so the main part is over here, because we are checking over here whether the stack dot peak has a greater height or not. If it's greater, then we are popping, and we are popping its height as well as its width, and then calculating the area. Here if you see, we are taking the width backwards as well, because we can go back to calculate our width, and then we are calculating the max area and updating the max area. Thank you for watching.